So, so today I am going to deliver a topic about water supply and wastewater engineering. So let's start that topic first. So these are the outline of my presentation, introduction of water supply and design period. So in this introduction of water supply, we have to study what is water demand and what is per capita demand and factor affecting per capita demand and population forecasting and what are the different kinds of quality parameters of water present and then treatment of water we have to study. So these are my introduction. Whenever to design a water supply scheme, we have to must first estimate the population for which the scheme should be designed, right? The scheme once the scheme is installed, no, so must cater for the demand of projected population up to some predetermined future date. A water supply scheme include huge and costly structure such as reservoir, dam, pumping, units distribution system, etc., which cannot be replaced or increased in their capacity easily because these are the vast. So once is installed, no, so this can be reused, and these are the community get satisfied, and that needs also called design period, right? Then as per the GOI manual, so what is GOI manual? So as per the Government of India manual, so these are the components and these are the design period. So these are the different types of components like water treatment unit, storage by dam. So water treatment units design periods is 15 years. Storage by dam is 50 years. Service reservoir 15 years. Pump house and electric motors and pump. These are the 15 years. So what is water demand and per capita demand? We have to study. So it is the annual average amount of daily water required by one person, include domestic, industrial, commercial and public uses. Or we can say that quantity of water required per person per area per day throughout the area in a city, right? Then it will expressed in LPCT. So LPCT means liter per capita demand. LPCT stands for liter per capita demand. So what is per capita demand? Per capita demands, it is accordingly defined as the total yearly water required of the city. Suppose I have to consider a city. In that city, total yearly water required of that city in liter divided by 365 into design period, and it must be in 270 LPCT, and it can be categories wise and classified wise. It is 270 LPCT as per the GOE manual. So according to according to Indian standard 1172 to 1963, water consumption under normal condition, right? So these are above are described in 270 LPCT. So 270 LPCT are classified into different uses categories like domestic supply, it should be in 135 LPCD. Industrial purpose, it should be in 50 LPCD. Demand for public use, it should be in 10 LPCD. And fire demand also, it is in 20 LPCD. And losses in water 55 LPCD. So accordingly, these are all total. When we add this, so it will be in 270 LPCD, right? Then moves to the variation in demand. So what are the variation? We have to read that. So it will be in categories, two categories. So one is maximum daily consumption. So in maximum daily consumption, 1.8 into average daily demand. It should be multiplied into 1.8 into average daily demand, right? Then maximum hourly consumption. So what should be the maximum hourly consumption? Maximum hourly consumption, it should be 1.5 into average 1.5 into average hourly demand, right? Then we calculate the population forecasting. So what are the importance of that population forecasting? So these are the three main factor responsible for growth or decline in population: birth, death and migration. So we we have to calculate upon these three methods: birth, death, and migration. So first we have studied to the arithmetic progression method. So what is arithmetic progression method? Now increase in population from decade to decade. So what do you mean by decade to decade? In 10 years we have to mention one decade. So it will be increases in population from decade to decade is assumed to be constant, right? First we have to understand the definition key. Increase in population from decade to decade is assumed to be constant. So and it will be formation of this formula Pn equals to Po plus n bar x. So we have then we move to the what are Pn, Pon. So Pn stands for the projected population after n decade. N will know the letter. So first you have to understanding the projected population after n decade. I mean, what are the decade? Then P naught. So what do you mean by P naught? P naught is the initial population, or we can say that last census. Last census means last year. Last year, what are the population we have to know first. Then n is the number of decades between number of decades. As you know that decades is variation in 10 years. So number of decades between now and future, right? Then x by average increase in population per decade. So first we have to calculation the decade to decade. After that we have to calculate the average increase population per decade. Then second method is geometric progression method or geometric increase method. So in this method percentage. So in increased population arithmetic in we have to calculate the last census, but there in geometric progression method percentage increase in population. What are the percentage? What is the percentage increases in that decade? In this method percentage increase in population from decade to decade is assumed to be constant, right? So let's understand the geo according to Government of India manual. It states that or recommends geometric progression method because it gives the maximum value out of other methods. So there are three methods we have to study. First one is arithmetic progression method and second one is geometric progression method. So this method it gives the maximum value out of the other methods, right? Then we have to calculate the geometric progression method. Pn equals to P naught 1 plus R by 100 to the power whole to the power n. So as we know that Pn stands for projected population after n decades. P naught population of last known decade. In last year, what are the population that is defined as P naught, and n equals number of decades between now and future. N stands for, and R is the geometric mean rate of increase in population per decade. So there is the formula R. R means geometric mean method. R1, R2 population per decade. We have to find out these way, right? Then this one is the last method, incremental increase method. So what do you mean by incremental increase method? In incremental increase method defined as first we calculate what arithmetic increase method, then geometric increase method. So both it is the combination of both arithmetic and geometric increase method, that is the incremental increase method. In geometric mean method we have to calculate the percentage, but in incremental increase method we have to study or we have to find out the combination of arithmetic and geometric increase method. Actual increase in each decade is found. That is the benefits of incremental increase method. And second one is average increment of increase is found, right? So population after n decade from present is given by Pn equals to P naught plus n bar x plus n plus 1 by 2 y. So that is the formula to find out the incremental increase method to given by Government of India manual, right? As you know that Pn is the projected population after 8 decade. As you know that P naught population of last known decade, a number of decades between now and future, because incremental. But what are the population increase in next future date? So that also you have to calculate. Then average increase of population of known decade, right? Average of incremental increase of known decade. That is the description or defined as that formula. We have to study that. No, there's a three method. First one is arithmetic progression method. In that method we have to calculate the increase in population from decade to decade is assumed to be constant. In geometric method, what should be the percentage increase in population decade to decade is to be constant, and incremental is the combination of arithmetic and geometric method, right? Then then we have to study the quality parameters of water. What are the quality parameters of water present in water, that we have to study now. So the properties of that certain qualities of raw water are termed as quality parameters. Mean properties of a certain quality. So what are the qualities present in that water, in the raw water, that is that term or that defined as the quality parameters. So water impurities. So these water impurities are classified as these three categories. It can be classified into these three categories. So first one is physical classification, second one is chemical classification, and third one is biological classification. We have to describe these things. Physical, what is physical classification, and what is the chemical classification, and what are the biological classification. Then moves to the physical classification. In physical classification, these are suspended solid, turbidity. In turbidity, so we have to study it. So what is turbidity, and how it is measured turbidity, what is color, how it is measured, taste and odor and temperature. Let's move to the what is suspended solid. So let's see, these are the suspended solid. So what is TSS? A total suspended solid. This is the low turbidity and this is the fineness of water. Then increase. Just so there are, let's see, you can see that no, so these are four containers, sorry, five container. In that five container, first container is normal water, insert the water, then increases the suspended solid container to container. So this is the low turbidity and it will be increases, and finally it will reach in the high turbidity, right? As you can see that total suspended solid. So this is the turbidity meter. So what is turbidity meter? Turbidity meter, we can find out the how much water is dissolved. Physical water quality parameters, in that physical water quality parameters, so turbidity is there, and how to measure how much turbidity present in that water. So first one is measure of turbidity is done by turbidity rod. So that is the turbidity rod actually. In that turbidity rod we can find out the how much turbidity present in that water. So let's move. Graduation are encrypted in rod. Graduations are encrypted in rods. So before going to measure, we have to know that 1 milligram per liter equal to ppm. ppm. So what is ppm now? Parts per million. ppm stands for parts per million. As depth of insertion, when we graduated rod are insert in that water, reading will be decreases as the depth of insertion increases. When when we that graduation rod are insert in that water, reading will be decreases, because when reading will be decreases, on that point we know that how much turbidity present in that water. So turbidity, which 1 milligram of silica producing 1 liter, of distilled water is taken as 1 unit. Right? Turbidity which 1 milligram of silica producing 1 liter of distilled water is taken as 1 unit. Then, so that was the turbidity rod, and second one is Jackson turbidity meter. So what do you mean by Jackson turbidity meter? So these are the methods actually we know or we find out the turbidity meter, right? So in Jackson turbidity meter, level of water is increased till image of flame disappear. Level of water is increased till image of flame disappear. This is the flame, this is the stand, and this is the container. In that container we have to add some water. When we add some water, level of water increases. When the level of water increases till image of the flame disappear, then this method is used only when turbidity is greater than 25 ppm. ppm means part per million. This method when it is used, or this method is used when the turbidity is greater than 25 ppm. 25 ppm part per million. So on that basis, on that time, we have to use the Jackson turbidity meter, right? This is the glass plate, this is the glass tube, and some person is seeing that when the level of water increases, till image of flame disappear, right? And this method is not used for drinking water. This method is not used for drinking water because it's 25 ppm greater than the turbidity. Then third one is Bailey's turbidimeter and nephelometer. So what is Bailey's turbidimeter? In Bailey's turbidimeter, when it is used, now turbidity less than 1 ppm can also be measured. When the turbidity of water less than 1 ppm, then we can also be used in Bailey's turbidimeter. So most widely used for domestic supply. Unit in nephelometer is NTU. It is the important. What is the unit of nephelometer? Nephelometer is NTU, nephelometer turbidity unit. Similarly, JTU, Jackson turbidity meter, and it should be the most important acceptable limit for the turbidity. Acceptable limit for the turbidity is 1 milligram per liter. 1 milligram per liter or 1 NTU. NTU stands for nephelometer turbidity unit, and permissible limit for turbidity is 5 milligram per liter, or we can say that 5 NTU, nephelometer turbidity unit. And cause of rejection, when it will be rejection, when 10 milligram per liter or 10 NTU. When it is 10 milligram or per liter or 10 NTU, it will be rejection. So that is the three methods. First one is turbidity rod, second one is Jackson turbidity meter, and third one is Bailey's turbidity meter. We have to find out or calculate the turbidity of water present in water, right? Then moves to the color. So what is color in water? Color is produced by suspended matter and dissolved matter. So there are different types of color we have to find out in that instrument. That instrument is known as tintometer. As you can see that color is measured by the instrument use of tintometer. So as you know, the true color, dissolved solid, apparent color, and suspended solid. So why color is objectionable? We know that water color is objectionable, but we have to find out that the particular color, what should be the color and what should be the present in that water, what color. So for that cases we have to use the instrument tintometer. The result is expressed in true color unit, TCU, true color unit, or Hazen unit, or we can say that the Hazen unit. So in color acceptable limit, acceptable limit is 5 TCU in 5 true color unit. It should be required acceptable limit in 5 TCU. It will be acceptable, right? Then test and order. So what is test and order? Taste and odor caused by chemical dissolve when some chemical and dissolved gases like H2S, methane. So that's chemical when present in that water or dissolved in water. We have to calculate the taste and odor. Taste and odor are objectionable because it is the carcinogenic nature, right? Taste and odor are measured by the instrument known as osmoscope. So that is the instrument osmoscope is used for to find out the taste and odor. Intensity of taste and odor. So how much intensity present in that water, intensity of taste and odor is measured in Dersud order number, or shortly we can say that ton. Ton it stands for Dersud order number. So ton equals to A plus B by A. As per the Government of India recommended ton between 1 and 3. Suppose we have collect some water. In that water, there should order there should order number should be 1 and 3 or 1 to 3. It can be acceptable, right? Then chemical parameters. In chemical parameters also various chemicals are there like dissolved solid, pH, alkalinity, hardness, chloride content, nitrogen content, phosphorus, fluoride and metal. In chemical parameter, dissolved solid are, we have to follow the Government of India manual. Government of India manual recommends the acceptable limit 500 milligram per liter in dissolved solid. For pH, acceptable limit 6.5 to 8.5. pH can be measured by color indicator like methyl, orange and phenolphthalein. This is the important, actually what should be the acceptable limit for pH. It can be varies from 6.5 to 8.5. Working range of methyl in orange 3.1 to 4.5, and working range of phenolphthalein it should be vary 8.6 to 10.3 as per the GUI manual. So this is the important hardness in water. So what is hardness? First we have to understand. Hardness is the concentration of multivalent metallication present in water. Whenever the multivalent metallication present in water, we know that key hardness may be induced due to Ca2 plus Mg plus and Al plus Fe2 plus. So major constituents of hardness are Ca2 and Mg2. Okay, hardness, and that hardness can be of two types. How much hardness and how much percentage of hardness present in water we have to calculate. So on that basis hardness can be two types. One is carbonate hardness, or we can say that the temporary hardness is also known as the carbonate hardness, and carbonate and bicarbonate of a multivalent ion. When carbonates and bicarbonates of multiplication ion are present, we know that that is the temporary hardness. Or we can say that carbonates and uh, bicarbonates of multivalent ion present in that water, we can say that water it should be temporary hardness of water. And when non-carbonate hardness or permanent hardness, non-carbonate hardness is known as permanent hardness. Chloride, sulfate, nitrate and multivalent ion. When chloride, sulfates, nitrates of multivalent ions are present in that water, then that hardness is called as the permanent hardness, and it is the non-carbonate hardness. So what should be the difference in temporary hardness and permanent hardness? No, temporary hardness is also known as carbonate hardness, and non-carbonate hardness is known as permanent hardness. So hardness of water, and little bit in temporary hardness we can remove the normal boiling of water. We can remove the temporary hardness, normal boiling water, but permanent hardness can't, right? So hardness of water is determined by titrating against EDTA. This is the most important. What is EDTA? EDTA, ethylene diamine tetracetic acid. Ethylene diamine tetracetic acid solution using also EBT, erichrome black tea. with the help of ETTA, ethylene diamine tetracetic solution also there, and EPT, erichrome black tea also there. This is the acceptable limit for hardness as per the GOI 200 milligram per liter, cause for rejection 600 milligram per liter. For domestic supply, it should be between 75 to 150 milligram per liter, and this is the chloride content. Chloride content acceptable limit 200 milligram per liter, and cause for rejection is 1000 milligram per liter. This is the most part of the nitrogen content also. So presence of nitrogen, presence of organic matter, and what should be the acceptable limit cause for rejection is the organic ammonia for acceptable limit, and cause for rejection is the nitrate, and this is the nitrite and nitrate. Nitrate acceptable limit is 0, and this is the toxic in nature, so not acceptable. But nitrate indicates fully oxidized organic matter, and it can be also indicate old pollution. Acceptable limit 45 milligram per liter, cause for rejection 45 milligram per liter, and this should be the main cause for the blue fever disease is caused due to nitrate. Actually, it is the important one. So how blue fever disease will be caused occur and due to the nitrate. So then finally we have reached the biological parameters. So most important organisms are pathogens because they are capable of transmitting disease like bacteria, virus, protozoa, helminth. So that is the most important biological parameters. Coliform hardness, aerobic letters, and E. coli, E. colitica coli. So these are the chemical form of biological parameters we have to see in that. Then moves to the methods of treatment. In methods of treatment, so there are various types of method in screening. First we have to screening that water and find out the aeration and sedimentation, coagulation, flocculation, filtration, disinfection, right? So these are the methods of treatment. What should be the fast treatment? So fast treatment is screening. Screening is done to remove the heavier suspended impurities. When we screening some water, first we remove the heavier suspended matter present in that water like plant, stone, animal, etc. Screening is generally adopted with the help of two types of screen. First one is coarse screens, and second one is fine screen. So what is coarse screen? It is in the form of bar of diameter 25 mm and spacing of 20 to 100 mm, and spacing this screen generally placed in 3.6 vertically and 1 horizontal. So as you can say that this is the bar of 25 mm spacing and 20 to 100 mm spacing. This screen are generally placed 3.6 vertically and 1 horizontal. Horizontal 1 and vertical 3.6. So then moves to the fine screen. So these are generally in the form of wire mesh. So this is, you can see that this is the mesh actually, wire mesh of size 10 mm, and fine screen is generally avoided as it get clogged frequently and requires cleaning at short interval, thus increase the operational cost. As per the GOI manual, Government of India manual, it is recommended to use the core screen instead of fine screen. As per the Government of India manual, it is recommended to use core screen instead of a fine screen and remove the finer particles other treatment stages. So we have to know that in screening there are two types of screening. First one is core screen and second one is fine screen. This is the aeration to remove the gases like H2S and CO2. Aeration adds oxygen to water, carry out the oxidation of undesirable substances like organic matter and oils. Aeration also removes the phenols and humic acid from the water. So what is aeration? Methods of it. So these are the methods of aeration. First one is spray nozzle method. In spray nozzle method, most efficient method because pressurized water is used to increase the surface area of water. When I spray the water, some mm, some some increased pressurized water is used to increase the surface area of water. So this is the first method, spray nozzle method, and second method is you can see that cascade aerator. In cascade aerator, this is the pipeline. When water flow through the different stages, it should be the most efficient, and not most efficient. Efficiency is about 40% in that method, cascade aerator. And third one is spray tower method. In spray tower method also, in that pipe water flow through the upstream side to downstream side, and this is the various types of stages when water flow through the upstream side to downstream side of different types of stages. It should be the best method to remove the iron and manganese. Best method to remove the iron and manganese for spray tower method. And this is the aeration. In third method, diffused air method, it has the highest operational cost. In the when we pressurized some pipes, so that are the diffused. In that diffused air method also we can find out the aeration. Then sedimentation. Sedimentation is also most important factor, as we know that what is first we have to understand what is sedimentation. Sedimentation is a natural process by which solid with higher density particle than that is fluid. Suppose we have a container. In that container water flows continuously. So in that process, which solid with higher density during flow time with higher density particle than a fluid in which they are suspended settles under the action of gravity. Due to the certain under of action of gravity, heavier particles are settled down that the container and other parts are flowing through. According so this is basically Stokes law. According to that Stokes law, we have to find out the sedimentation. So sedimentation tank is basically two type. One is Quiescent type and the second one is continuous type. What is Quiescent type? Quiescent time has a detention time. Detention time means when water flows continuously. Detention time is 24 hour and cleaning interval after detention time we have to cleaning that sedimentation tank, and it should be the interval of 8 to 12 hour. Tank is designed for maximum daily flow 1.8 Q. Q stands for discharge. So this is the basically design